Last time on X-Men, we had these famous number systems. Do you remember what they were? Okay, one of them was the reals. So this is example 1.5.13. Yeah. Famous number system subset inclusions or relations. All right, let's take a look. What's the first number system that we had? The very, very first one that we talked about? The natural numbers. What was the second one? Integers. What was the third one? Rationals. Then. All right. Question, what's the subset relationship between naturals and integers? Subset. Is it ever possible that n is equal to z?
No.
Why not?
Because z includes more than...
Brought to you by the number 0. Today's class is sponsored by the number 0. Right? So a strict inequality doesn't have the line underneath. This inequality allows its children to watch TV. This one is much stricter. It's a strict inequality. Right? Thank you. I'll be here all week. All right, what's the next one? Which one's a subset of which one? Okay. Is it ever possible that z is equal to q? Why not? Sponsored by the number 1/2. Okay, what's next? Subset. Is it ever possible they're equal? Pi. Okay, and then what's next? Subset. So that's the inequality chain. Please prove that for yourself in your free time. How do you know that pi is irrational?
I don't, it's just...
Okay, good. So then you have to prove that, right? That's something that a mathematician would say you can't bet your life on it unless you have a demonstrative understanding of that. Okay, so the next thing that we're going to talk about is set equality. So we say, this is a definition. Sets A and B are equal, denoted A equal B, if and only if, 1, A is a subset of B, everything in A is also in B, and 2, B is a subset of A. When are two sets equal?
When they share everything.
When, we got to be careful though, right? What's the formal construction?
When A is a subset of B.
Yeah, when everything in A is also in B, and when everything in B is also in A. Be careful, this is the first time that most of you might have seen, unless you've seen Math 22, this is a very, very special equal sign. This is a non-numeric equal. What I mean to say is, what's on the left-hand side?
Set.
A set. What's on the right-hand side?
Set.
Set. That's very, very different in flavor than when I say 2 equals 4 over 2. That's a numeric equality. This is not a numerical equality. Okay, so one of the things that we're going to see in this class, and we're going to need this for later, is the direct proof that A equals B. So if I give you two sets and I want to know that they're equal, how do you do that? To show sets A and B are equal, we do step 1. Could you guess what step 1 is? Okay. Could you guess what step 2 is? Show B is a subset of A. Step 3. What's step 3? Yeah, drop the mic. All right, cool. Don't write that on your page, right? That's, yeah. Conclude A equal B by definition. Okay, let me ask you this. How would you show A equal B, A is a subset of B? How would you show that? Yeah, it's that one, right? How would you show B is a subset of A? That one. Yeah, there's an indirect proof of this thing, but it's, I'm not going to go, if you're in a Math 22 class with me, we'll spend like 2 or 3 days on this. In this class, 10 minutes is sufficient. It's called upper division, right?